Welcome to Astronomy Daily. I'm Anna, and today we have a packed show covering some of the most fascinating developments in space exploration and astronomy. We'll be checking in with NASA astronauts Butch Wilmore and Suni Williams aboard the International Space Station, where they've been experiencing an unexpectedly extended stay. We'll hear directly from Suni about what it's like living in space for so long, including her surprising revelation about forgetting how to walk. We'll also dive into some incredible discoveries from Asteroid Bennu that have scientists rethinking how life might have emerged in our solar system. Plus, we've got an intriguing new study about how supermassive black holes prepare their cosmic meals, and we'll take a look at some spectacular geyser activity on Mars. Stay with us for all this and the latest updates from the European Space Agency Conference, Day 2. A lot to cover, so let's get into it. The situation aboard the International Space Station has taken an interesting turn for NASA astronauts Butch Wilmore and Suni Williams. What was initially planned as an 8-day test mission has stretched into a 7-month stay, following concerns about their original return vehicle, Boeing's Starliner spacecraft. NASA made the decision back in August to switch their return plans to a SpaceX Crew Dragon capsule, determining that the Starliner posed too much risk. The spacecraft that will bring them home is already docked to the station, having arrived with the Crew 9 mission in September with empty seats specifically reserved for Wilmore and Williams. Their return journey, originally scheduled for February, has now been pushed to late March. SpaceX requested additional time to complete processing of a new Crew Dragon capsule that will replace theirs for the upcoming Crew 10 mission. This scheduling adjustment is part of NASA's carefully coordinated space station operations, where timing is crucial to maintain proper staffing levels. The extended stay has recently attracted attention from various quarters, including President Donald Trump, who made an unusual intervention into NASA's operations by publicly calling on SpaceX to return the astronauts as soon as possible. However, any changes to the current schedule could potentially leave the station's U.S. contingent understaffed, complicating the maintenance of critical systems aboard the ISS. Despite the extended mission, both Wilmore and Williams remain in good health and continue their scientific research aboard the station. They're part of a 7-person crew currently orbiting Earth, working alongside their international colleagues to maintain the space station's operations and conduct valuable scientific experiments. While their stay has been considerably longer than planned, the astronauts have adapted to the situation, maintaining their professional duties while awaiting their eventual return to Earth aboard the SpaceX vessel. Still, Elon says he's bringing them back soon, so I guess we'll have to wait and see how this all plays out. While we're talking about Suni, Massachusetts native Suni Williams recently shared some fascinating insights about her unexpectedly extended stay aboard the International Space Station. After nearly 7 months in orbit, she's experiencing some unique adjustments to life in microgravity. During a recent video call with students from her alma mater, Needham High School, she revealed that she's actually trying to remember what it feels like to walk. As Williams explained, the sensation of being in space feels more like swimming or flying. She hasn't walked, sat down, or even laid down in months. There's simply no need to in the weightless environment of the space station. You can just float wherever you are and close your eyes to rest. The extended mission has also changed how Williams maintains connections with her loved ones back on Earth. She's developed a particularly close routine with her aging mother, making it a point to check in with her almost daily. These frequent calls have created a different kind of relationship than what they had initially planned for what was supposed to be a brief mission. Despite being physically separated from Earth by hundreds of miles, Williams doesn't feel isolated. Her busy schedule keeps her thoroughly engaged, and modern communication technology allows her to stay connected with people back home. The ability to maintain these connections has helped make the unexpected extension of her mission more manageable. When asked about the mission's extension, Williams admitted it came as quite a shock. While she and her crewmate Butch Wilmore had anticipated their test flight might last longer than the planned 8 days, they hadn't expected a stay of this length. However, they've adapted to the situation, maintaining their professional duties while making the most of this unique opportunity to spend additional time conducting research and experiments in space. In other news today, in a remarkable development from NASA's Osiris-Rex mission, scientists studying the samples returned from Asteroid Bennu have made an extraordinary discovery. The asteroid grains contain such an abundance of life's chemical building blocks that researchers are now pondering a fascinating new question. Why didn't life emerge on Bennu itself billions of years ago, when conditions seemed perfect for it? The samples revealed more than 10,000 different organic chemicals, including 14 of the 20 amino acids used by Earth-based life to create proteins. Even more intriguingly, scientists found all 5 of the nucleobases that our DNA and RNA use to encode genetic information. The samples also contain significant amounts of ammonia and formaldehyde, 2 chemicals that can combine to form complex molecules essential for life. Evidence suggests that Bennu's parent body once had liquid water in its interior. Salt crystals found in the samples, similar to those in dry lake beds on Earth, indicate the presence of ancient briny fluids rich in bioessential elements like phosphorus and sulfur. Rather than surface lakes, scientists believe the asteroid had something more akin to a muddy surface with pockets of fluid underneath. While these findings don't suggest that life ever existed on Bennu, careful examination revealed no cellular structures or chemical fossils. They do support an important theory about how life might have emerged on Earth. The evidence suggests that asteroids like Bennu could have been among the cosmic delivery services that brought water and life's chemical building blocks to our young planet, as well as to other worlds like Mars and Europa. Remarkably, these findings come from analyzing just 30% of the 120-gram sample returned by Osiris Rex. The remainder is being carefully preserved, including 7.5 grams that will be stored at minus 80 degrees Celsius for the next 50 years, waiting for future scientists with even more advanced analytical techniques to unlock its secrets. As one researcher noted, we're just scratching the surface of what these samples might tell us about the chemical foundations of life in our solar system. Now, you know I love a good black hole story. Well, here's today's. Just as we're careful to blow on hot food before eating it, it seems black holes have their own way of cooling down their cosmic meals. New research using NASA's Chandra X-ray telescope and the Very Large Telescope has revealed fascinating details about how supermassive black holes prepare the matter they consume. These cosmic giants, which can weigh billions of times more than our sun, launch powerful jets that strike the hot gas between galaxies and galaxy clusters. When these jets collide with the hot gas, they create large cavities and trigger the formation of intricate filamentary structures made of both hot ionized gas and cooler gas. This process acts like a cosmic cooling system. The cooler gas eventually falls back toward the center of the galaxy cluster, where it feeds the supermassive black hole. This feeding process then triggers more outbursts, creating a self-sustaining cycle. It's as if the black hole is preparing its own continuous buffet, cooling down each serving before consumption. The scientists found clear evidence of a connection between the brightness of both hot gas filaments and warm gas tendrils. This relationship provides the first concrete proof of how black holes regulate their feeding process, similar to the gaseous tails seen in what astronomers call jellyfish galaxies. But this discovery has implications beyond just black hole feeding mechanisms. These cool filaments of gas are thought to provide the essential ingredients for new star formation. This means the relationship between hot and cool gas could be fundamental to both galaxy growth and supermassive black hole development, revealing a complex cosmic dance that shapes the evolution of our universe. The research team made these discoveries using innovative techniques that allowed them to distinguish hot filaments from other structures, including the massive cavities carved out by black hole jets in vast hot gas clouds. This new understanding of how black holes prepare and consume their meals is helping us better comprehend the complex mechanisms that drive galaxy formation and evolution. Now let's take a journey to Mars' South Polar region, where an extraordinary seasonal display is currently underway. Recent observations from NASA's Mars Reconnaissance Orbiter have captured a spectacular phenomenon that occurs every Martian spring: natural geysers erupting from the planet's surface. During the harsh Martian winter, a thick blanket of carbon dioxide ice accumulates across the polar region. As spring arrives and the sun climbs higher in the sky, something remarkable begins to happen. The sunlight penetrates through this transparent ice layer and gets absorbed at its base, initiating a fascinating process. The warming sunlight causes the bottom layer of ice to transform directly from solid to gas, bypassing the liquid state entirely. As pressure builds beneath the ice sheet, the carbon dioxide gas searches for escape routes through any weaknesses in the frozen surface. When it finds these weak points, it erupts in dramatic fashion, sending plumes of gas and dust shooting upward in geyser-like formations. These eruptions aren't your typical Earth-bound geysers. They're unique Martian phenomena, captured in stunning detail by the HiRISE camera aboard the Mars Reconnaissance Orbiter. This powerful instrument can photograph vast areas of the Martian terrain while still detecting features as small as a kitchen table, giving us an unprecedented view of these seasonal displays. This annual cycle of freezing and sublimation creates an ever-changing landscape in Mars's polar regions, reminding us that despite its cold, desert-like appearance, Mars remains a dynamically active world. These geysers represent one of the most visible and dramatic examples of the ongoing seasonal changes that continue to shape the red planet's surface. In major developments from the European space sector, the European Space Agency has announced several groundbreaking initiatives during Day 2 of the European Space Conference. A significant milestone was reached with the signing of a launch agreement for the Plato mission, an ambitious project designed to search for potentially habitable planets around sun-like stars. The mission will launch aboard an Ariane 62 rocket from French Guiana in late 2026, marking the first science mission to fly on the new Ariane 6 launch system. Plato will be positioned at the Sun-Earth Lagrange point L2, where it will study thousands of exoplanets in unprecedented detail, with particular focus on Earth-like worlds. The conference also saw the establishment of important new partnerships, including a significant agreement between the European Union and African nations. The African-EU Space Partnership Program represents a major step forward in international space cooperation, focusing on using Earth observation technology for sustainable development across multiple continents. In the quantum technology sphere, progress continues with the advancement of EuroQCI, an innovative project aimed at creating a quantum communication network across the European Union. This network will utilize both fiber and satellite links, and by 2026, it will be integrated with IRIS-2, Europe's new secure satellite constellation. European Commissioner for Defense and Space emphasized the vital importance of maintaining a strong European presence in space, noting that the continent's space capabilities serve not only European interests but benefit all of humanity. These developments reflect Europe's growing commitment to remaining at the forefront of space exploration and technology, while fostering international collaboration and scientific advancement. Well, that's all for today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space exploration and astronomy. If you'd like to stay up to date with all the latest space and astronomy news, head over to astronomydaily.io. There, you'll find our constantly updating newsfeed and can listen to all our previous episodes. And while you're at it, why not follow us on social media? You can find us as Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, and TikTok. Don't forget to subscribe to the podcast. We're available on Apple Podcasts, Spotify, YouTube, and wherever else you get your podcasts. Until next time, keep looking up and stay curious about our incredible universe.